episode, I mentioned about two aspects of the growth of industrial automation and how it started and where it was applied. I had mentioned to you that the first applications came out of replacement of Waterline Arc sets, and that too in paper industry, which adopted that technology. Now let's have a look at the Waterline Arc set. A Waterline Arc set is nothing but an AC motor which drives a DC generator, and the DC generator drives a DC motor. Now, in order to get some amount of variation in speed in the DC motor, what one does is the AC motor runs on fixed speed, it runs a DC generator. Now you can vary the output of the DC generator by changing the flux of the DC generator or the field of the DC generator. By doing that, you actually vary the voltage coming out of the DC generator, which goes into the armature of the DC motor, and as a result, on varying the voltage, the speed of the DC motor varies. That is the Waterline Arc system. What it did was that when thyristor drives came in, and the technology came in where, in a thyristor drive, you could take in an AC input and give a variable DC output. All it did was replace the AC motor and the DC generator. And instead of the AC motor and the DC generator, the thyristor drive came in between, and therefore you had a variable speed coming out of the DC motor because the armature of the DC motor was varied and you could get the output. The thyristor drive would get the AC input and it would give a variable DC voltage which would be put across the armature of the DC motor, and as a result the speed could be varied. Now if you wanted some extra fine-tuned control, then you could put a thyristor drive on the field of the DC motor and vary some amount of speed by varying the field. So this was in principle how the thyristor drive replaced the Waterline Arc system. Now let's see the paper machine. In the paper machine, you will find that a paper is manufactured out of a machine where the input is pulp, or it's on a liquid form. The pulp comes in, it goes through what is known as a wet section. Then it goes to a press section where basically, you press the material and make it some sort of a sheet, but it is still wet. Therefore, it then goes to a dryer section where it dries up, and then calendar which irons it out, and then you take it on a reel, and that's how the paper is manufactured. Now, there are two types of paper machines. In the olden days, used to be what is known as line shaft drive. Even though there are various sections, I mentioned to you already about the various sections. There are various sections. A large AC motor with a fixed speed would actually be connected to the paper machine, which will all the mechanical parts will be connected through a line shaft. And the line shaft will be driven by the AC motor. And what would happen is you still needed some variation in speed in the subsequent sections of the paper machine, because as the paper dries up from a liquid form, and then as it gets calendared and as it actually reels up, there is some sort of a shrinking of the paper, and while it shrinks, so each section has to actually synchronize itself so that the paper doesn't break. And therefore, in order to get these variation in speed, what one did was they used to have cone pulleys on each of these sections, which would vary the motor speed slightly, the machine speed slightly, and as a result, you would get a paper coming out and reeled up. Now, if you go for larger paper machines, obviously, mechanically connected will not be very efficient, and therefore what used to happen was each of the sections used to be driven directly by its motor, and the motor used to be connected to a Waterline Arc set, and then actually you will have number of these Waterline Arc sets driving each of the section of the paper machine, and one had to synchronize it, and therefore synchronization used to occur, and there used to be what used in the paper language they used to call it draw variation, and that is to actually have differential speeds between the sections, and this would be done by means of some amount of speed control which will actually coordinate. So this was in the Waterline Arc System, and that is where we supplied our first drive system to Andhra Pradesh paper mill, where in order to control the draw, we actually put these field converters on the DC motors so that slight amount of speed can be varied and you can get good quality paper. So this was the first type of application and market that opened up for thyristor drives in the paper industry. And as they became, we tried to concentrate on this area. Not only we, most of the other companies also concentrated on this area. And the first applications came for line shaft drives, where people would actually change the fixed speed motor to a variable speed DC drive. These are all small paper machines which used to manufacture 30 tons per day to maybe 50 tons per day, not more than that. And this was a pretty big market. Also, at the same time, lots of paper mills were coming. In fact, India was, I think, probably at the peak of its industrialization at that time. A lot of paper mills were coming, and all these paper mills that were new paper mills that were coming were all looking for thyristor drives, and the old ones that were there, they were going in for replacement. As far as the sectional drive was concerned, it's much more complicated, and only the large paper mills were looking at it, but that market also opened up, which I will cover in the next section. Thank you.